Hello, my name is Shanze Zhong. My presentation topic is potential of selecting high-yielding fava bean lines through an indirect method of measuring biomass production using Canopio, and my supervisor is Dr. Kadir Artikari. Generally, to start with the introduction, fava bean is a globally important and productive cool-season legume crop, and it plays an important role in soil fertility in cropping systems, human food consumption, and animal feed. And it has a long cultivation history, which may originate from the Middle East. Currently, it has already distributed to many countries. When we look at the third bullet point, the production of well-being is suffer from both abiotic and biotic factors. For abiotic factors, temperature and moisture should be the main factors. Dry and cold environments may lower its production. Moreover, if optimal and supplemented irrigation can be provided for well-being, its yield will increase. For biotic factors, fungal disease and virus can severely threaten the yield of well-being. For example, faba spec can cause a 90% yield loss by affecting leaves, pods, stems, and seeds of well-being, and the virus are more challenging due to its uncertain transmission route and the lack of effective treatment method, especially being leaf roll virus and being yellow mosaic virus. Proper field management are selecting optimum sowing date and controlling the plant density, which are beneficial to the yield. In Australia, most soybean can be exported to satisfy human consumption, and it has a yield average over other pulses in recent experimental sites. Therefore, its yield potential may be underestimated. Last but not least, the canopy method is non-destructive compared with the conventional fresh biomass and over-dried biomass after clipping method, and is more affordable compared with the UAV biomass analysis. The aim of this study is to find an indirect, efficient, cost-effective, non-destructive, and practical method to measure biomass production to select for high-yielding breeding lines. An investigation was carried out whether the Canopy app is a good fabric biomass measurement based on imagery technique. Another aim of this study is to find whether the canopy percent and the plant height are correlated to find out if only the plant height can be taken as a measure of biomass production. The experiment was laid out in a randomized cut-complete block design with three replicates. 13 diverse genotypes were chosen based on their pedigree. These 13 selected genotypes were listed on the following table. Canopy samples, which could represent biomass production, were randomly taken from the middle three rows of each plot for 3 times using the Canopy app installed on the mobile phone with same height, uh, which more than 60 centimeters in order to capture the picture from the whole plot, as you can see in the right figure. It was important to take a background photo after 3 images to distinguish the record from the different plots to avoid missing shots. Plant height measurement samples were taken on random for plants starting from the bottom of the plant to the highest tip of the top leaf. Both of their means were obtained for the analysis of variance from the gene state and the Excel plot. The growth of plant height during the experiment was significant. The mean of bean plant height was at the bottom of table. As a result, the plant height difference between week 1 and week 2 was the smallest, and that of difference between week 2 and week 3 was the largest. The plant height of all faba bean genotypes grow slowly in the early stage and grow quickly in the later stage of the experiment. The plant height of all genotypes of bean at Narrabri continuously grew through the 5 weeks of the experiment period within an increase of more than 30 centimeters, with the lowest plant in week 5 was marked as blue and the highest one was marked as black. Moreover, most bean genotypes except the blue one reached more than 60 centimeters. The red ones was higher than the average and the rest were lower than the average. The increase of canopy percent was very significant as well. The mean of being canopy percent was at the bottom of table. Similarly, the canopy difference from week 1 to week 2 was also the smallest, and that of difference from week 2 to week 3 was the largest. It also showed the similar trend as plant height, which means grow slowly in the early stage and grew quickly in the later stage of the experiment. The percent of canopy or of all fiber bean genotypes or also increased for 5 weeks with more than 40% canopy cover gap. Similarly, the lowest canopy percent in week 5 was marked as blue and the highest canopy percent in week 5 was marked as black. Most Fabian genotypes except the blue one exceed more than 80% canopy cover. The red ones were higher than the average and the rest were lower than the average. The correlation was highly significant and strong, more than 0.97. It means either plant height or canopy percent can be used as a measure of biomass production. However, some points were still far from the correlation line, which could have an impact on R squared. Moreover, we could see the weekly correlation between plant height and canopy percent ranging from 0.59 to 0.91, and week 3 had the largest significant level, which means that it reached the optimum date on the third measurement. This correlation step would be more accurate to determine the level of biomass production by combining both plant height and canopy percent data than observing a single index. For more details, the correlation R square between each five bean genotypes were very close, which means each genotype has a similar correlation between plant height and canopy percent. Therefore, these two variables would provide a reliable method of biomass estimation on any genotypes. As you can see, I used the figure to show the trend. The growth rate reached its peak in week 3, which was probably the middle stage of flowering, and it was the best time to observe. After that, the growth rate would slow down. It was still at a relatively high level. From other research findings, we can conclude this point. Middle of flowering time is optimum time to observe. Time is limited. The difference of correlation is more obvious than other hours. Biomass production by combining both canopy percent and plant height is more accurate and reliable. Moreover, multiple observations combining both plant height and the canopy percent data before yield at the same time of each week can ensure the accuracy of yield prediction based on our experiment. And the limitation are no actual biomass cut and long awaiting fiber bean yield. The correlation between plant height and canopy percent can be a feasible method to make a biomass production estimation rather than using destructive biomass measurements. Due to non-comparison between the conventional destructive and canopy method, and it has difficulty on weighting the ground yield data after few months. The potential issues can be classified as incomplete canopy image capture and uneven plant height errors. The former one was likely to be affected by wind at nearby, which led to loss of canopy percent. The latter one could be caused by uneven plant height, especially in the early stage. After dealing with these potential issues, the high-yielding fiber bean genotype can be found by comparing the biomass estimates through plant height and canopy percent. Lastly, the research implicates further researchers a potential method to estimate biomass production to achieve high yield. I would like to acknowledge my supervisor, Dr. Ardikari at the University of Sydney, for providing me the opportunity and resources to work on the Fabian trail, teaching measurement and data analysis skills, report writing, and providing valuable feedback. This field experiment made me a standing on Fabian. I would also like to acknowledge my auxiliary supervisor, Dr. Adbar Sadiq, for his guidance in field taking observations. Last but not least, I would like to thank all staffs at the PBR and Camperdown who had ever helped or encouraged me to complete this project. These are the references we use. Thanks for watching.